Hello, in this video we will learn how to transpose matrices. So to transpose is to turn rows into columns and columns into rows while keeping the same order. So what do I mean by this? I mean that the first row will become the first column in the transpose of a matrix. Another way to denote this is that if A is a matrix, and we'll say that it's matrix with entries Aij. So this notation right here means that their entries, just that the rows are represented by I and the columns are represented by J. So you might see this kind of notation in your textbooks or things like that. And so if we get the transpose of A, we would actually have this new matrix, which is Aj I. So what does this mean? This means that whatever row it was in, it now becomes the column. And whatever column it was in, now it becomes the row. It might still be a little bit confusing. So let me give you an example. Let's say that we have 1, 2, 3, 4, 5, 6. So let's say that this is equal to A. Now what is A transpose? Well, our first term right here is A11. We say that in the transpose, we flip these two numbers, right? So it's still A11. So in our matrix, in our transpose, 1 is still found in the first row, first column. But now let's look at the 2 right here. The 2 right here is found in the first row, second column of A. But now, getting the transpose, we will flip the subscript. So it will now be found in the second row, first column. So in our second row right here, first column right here. So the 2 is now underneath the 1 instead of next to it. We will repeat the same procedure for all the other ones. So the 3 is in our first column, so now we'll put it in our first row, and it's in our second row right here, so we will put it in the second column. So here comes the 3. Now let's do the 4 is in our second row, so we'll put it in the second column, and it's in our second column, so we'll put it in the second row. So right here, 4. 5 is third row, so we will put it in the third column right here, and it's in the first column right here, so it's gonna be in our first row right here. And the 6, same thing. So this is what the transpose means, that whatever was in Ij, it is now in Ji. So we flip everything. You might notice that here the number of rows was equal to 3, and here the number of columns is equal to 3. So as you might recall, the size of a matrix is given by rows times columns. When you get the transpose of that, you will actually now get the columns times the rows. But like the number. But it still represents the rows, but of the transpose, times the columns of the transpose. So as an example, the size of A is rows, so 3 times number of columns, 2. And the size of the transpose right here is 2, which is the number of rows, times the number of columns, 3. So if this were m and this was n, now this one is going to be n, m. So m, n, and we get the transpose is equal to n times m. So that is something to keep in mind and to know.